So I will ask the question, why are we here, right? So why are we here as people, as a civilization? Why are we here? And the brief answer is we're lucky. We're humongously lucky to be here. And cosmologists tell us that there are multiple universes, right? And they expand and compress, et cetera, So we happen to be in a good universe. And there are a number of, a small number of potentially habitable planets, and we happen to be one of it. And I could take you through the science, but we're at the right distance from the sun, so we're not too far to be cold enough and to be frozen. We're not too close to boil. We have the right chemical composition of the Earth's interior. And that allows us to have an atmosphere that holds the outgoing radiation. It warms us, not too much, not too little. We're just in the perfect. We're just the perfect planet of the perfect size, at the perfect distance from a sun in some random galaxy, in some random universe, because there are many of them. So beyond that, we also happen to be in the brief history of our planet, about 4.6 billion years. You see it. You see it here. This is a rough estimate of temperature and precipitation on the planet. We just happen to be in a very, very lucky and happy place in the history. For example, there's been many. I can point to them here, right? So there have been many ice ages, right, where most of the planet was frozen, and I'm very lucky and grateful that we didn't live then. Well, we couldn't have lived then, right? Then we went through a long period, right? Jurassic, Cretaceous, Triassic. These are the large, crazy animals roaming the earth, and all these tropical plants living in the Arctic, etc. And those times were way too hot for the development of a human civilization. And then extremely recently, right, the Homo sapiens developed, and let's say modern civilization is and human civilization, development of agriculture in Mesopotamia, etc. Let's say 2,000, 3,000, few 10,000 years, let's say, right, human civilization as we know it. We are really a blip in the Earth history and in the history of the universe, and we just happen to be here, because the conditions weren't perfect earlier on, right? We have had life on Earth from the almost from the very beginning, 2-point-something here for right, but it was either too cold or it was too hot, and really in the past. We had the last glaciation, the last glacial maximum was 20,000 years ago, and we've had a slight warming of the planet since this last glacial maximum, right? But then previously to that, right, we had a cooling of going from, say, 50 million years ago to the present. Then and it was too cold for humans. And then only in the last 10,000 years, right, the retreat of the glaciers in the northern hemisphere have made the Earth really perfect for the development of agriculture, right? The soils have the right chemical composition, etc. We are the climate overall in most places is fine for development of agriculture, and here we are, right? So I guess my point is that we are really lucky, and it's a very delicate balance, right, where human civilization it really thrives on our planet, and we need to keep it that way. So. Also, we see from here that climate has changed continuously, right? So we also have to ask, as scientists, like, what is it is what we're doing now special in any way, right? So here's a summary. This is from Archer 2010's textbook, some of his arguments, classical arguments. The one that I will point to as, for me, the most important is number 2, the speed of change. So these are just some rates of the present warming, 0.7 degrees Celsius per century. Over the 21st century, we're going to increase our temperature about 2 to 5, 2 to 6 degrees Celsius, in that range. That's what the IPCC report tells us. And the truth is that we haven't found in the geological record up to now any equivalent to this kind of rate of change, right? And we know that this is produced by greenhouse gases and the CO2, and we are seeing incredibly fast, right, exponential rate of CO2 increase going with the population, etc. And geologists, right, and paleoclimatologists are furiously digging through the geological cores, trying to look at instances in the past where we can find, right, in such a small amount of time, right, changes in temperature that are comparable to this. We're talking about a change of, right, in 100 years or 200 years. This is nothing geologically speaking. And we're having trouble finding any such events, right? We would like to find them so they would help us predict what's going to happen next. So we are really doing a global, right, geophysical experiment that we've never encountered before in the history of the Earth. So what's really important and to keep in mind are not the absolute temperatures, and they're not the absolute, really they're absolute CO2 levels. Our CO2 is 410 parts per million or so, right? And that's not an exceptional number in any way. There have been instances in the past, like 30 million, et cetera, where atmospheric CO2 we know was 2,000, 3,000 parts per million, right? And there have been times when CO2 was lower than what is today, right? In the past million years, it's been going from 190 to 290, et cetera. What is exceptional is that we are changing CO2 at the pace that is absolutely amazing, right? We have changed in 100 years CO2 more than the natural fluctuations on 100,000-year timescales. So this is what is truly exceptional, right? CO2 as a gas is going to be dangerous chemically for us, right? At about 3,000, if we have chemists in the room around there, right? So it's not per se the absolute value, but the rate and increase is what is driving this the huge climatic changes. There are many arguments, and of course I don't want to go through. Come to my class at 3. Well, we can go through climate dynamics and the implications of climate change. But among just one other issue that we wanted to argue is that one of the big implications are the huge changes in ocean chemistry, right? Ocean acidification, and this is critical. Basically, we think by year 2100 we're going to reach, we're going to acidify the ocean and reach a pH lower than it's been in the past 30 million years or so. So, and this is important not just for destroying corals and plants and animals with calcium carbonate shells, but it's also decreasing the capacity of the ocean to take up future carbon dioxide. So it's decreasing the capacity of the ocean to act as a sink of carbon dioxide. So there's water chemistry that's involved here that's extremely important. So this was my philosophy side, my science slide. So let me show you a couple of slides on the sociology of science. So is there a consensus on the human impacts on anthropogenic global warming? And I just wanted to tell you that yes, there is a consensus, and 98% or more of climate scientists actually agree that human behavior caused global warming. And there are by now many scientific papers that analyze, right, the bibliometric studies of the peer-reviewed literature, large studies looking at the entire literature. And of course, right, we have the IPCC, which is a community effort. We have the U.S. National Climate Assessment. It's complete scientific consensus here, right? So. In contrast, what is absolutely staggering is that 27%, so this I'm finding it from the most recent review I could find was a Pew Research, October 2016 statistics. So 27% of Americans think that almost all scientists agree on this point, right? So more than 98% of climate scientists agree that human behavior causes climate change, and only 27% of Americans are aware of that, right? In contrast, right, 60% the rest thinks that there is significant disagreement among scientists. I mean, this is truly, truly, truly staggering, right? I mentioned the numbers look better in Europe than this, but I actually need to, I'm not a sociologist, but I really need to look up these distribution of statistics over different countries. So, okay, so then okay, to go further from here, right? If only, so this is what Americans think about the climate consensus, right? So the next point is, what do Americans think specifically, right, about whether the Earth is warming as a result of human activity, right? And the result is on the bottom is about 48%. So on the left graph, right, you see that the percent of US adults who say the Earth is getting warmer because of human activities has pretty much stayed constant in time, right? From 2000 in the past 10 years, and I think even if you go further back, it hasn't changed too much, right? So they're very modest fluctuations, right? I was expecting this to change more over time than it has, right? But then of course we see that it's that the percent of U.S. adults who believe in this, right, depends very strongly on whether you're a Democrat or a Republican, right? So we have seen, right, and we know very well that this is about political divides, right? So whether you believe in climate change or not, or whether you believe in the scientific consensus of it, is not a scientific decision, but it's really is completely driven by your political affiliations. And this was one other plot from the same Pew Research that I found. So this is percent of US adults who say the following about global climate change. And to me, I just found it a couple of weeks ago, and I'm just in awe of it. I've been, wow, since then. Climate scientists understand very well whether climate change is occurring. Only 33% of US adults think that that is the case. So only 28% of US adults think that climate scientists understand the cause of climate change, right? And only 19% think that climate scientists know the best way to address it. I would agree with that one. I mean, yeah. But the rest, right? It's if you were to do this for a physicist or a doctor, right? Does a doctor know how to do his job, and would you trust a doctor with your specific health problem? I bet you it would be, right? It wouldn't be perfect, but for physicists, it would be maybe 80, 90% or something. 33%. They do not consider us a science, right? They do not acknowledge that this is a science. And it's very interesting that 33%, right, goes with, it's similar to the numbers that I was showing you, before. Trust scientists a lot for full and accurate information on causes of climate change. Only 39% of the U.S. population trust scientists on information, right? And then this one is amazing. So research findings influence. So 32% of the U.S. adults, right, think that climate scientists research is driven by best available evidence. Only 32% of them think that, right? Instead, they say, well, really, they want to advance their own careers, and that's why, right, that's their research is driven by that. Or they have political leanings of some sort, or they really want to help their own industry, I guess climate science industry, right? I mean, this is really staggering, right? So I guess this brings me to my final slide. What is it that we're gonna do, right? As scientists, I'm at a complete loss. I hadn't looked at these numbers in a long time, and I've just disregarded them, and I was just teaching my science and, studying my physics. And then when I saw these, I should really end on a positive, right? So how can we as scientists address these public misperceptions, right, and firmly establish the non-political, non-partisan nature of climate sciences? I mean, you as coming from different, right, non-scientific fields, what are we doing wrong, right? What is it that we're doing wrong? How do we get the public and businesses to trust us, to trust that we do science, right? And that, yes, we have, degrees in physics and geochemistry and whatever, right? And that we are just like a physicist and we are just like a doctor and we are professionals. We're not doing this for any partisan anything, right? People ask me, do you believe in climate change or do you believe in this? And I'm like, what? Believe? No, I can give you statistics. There's 80% chance that this, 60% chance than that. There's no belief system that's involved here. Everybody asks you this question, right? Oh, so you believe in climate change? It's like, so I think the biggest thing is that to think about how to do more climate and sustainability and clean energy science, research and education, right, in our own institutions, and of course outreach to the public. What are the smartest ways to do this, right? Of course, we need additional, not less, right, private and public resources at this critical juncture, right? I would argue that the numbers that I showed you really tell us that we need more public support for sciences, not less, right? And then my pet project, maybe one day I'll achieve it, is to engage here locally the university and the business leadership on these issues and explore the creation of interdisciplinary centers, right, on climate, energy, and sustainability at the interface of disciplines. A few of us have discussed these kind of things, and maybe Wharton and business partners would be interested in following through. Thank you.
Thank you very much.